Hi everybody, Dr. Nigro here. I wanted to do a quick screencast to give you an example of how to work a stoichiometry problem that involves energy. The reaction we're going to be looking at today involves aqueous magnesium chloride reacting with iron metal to produce magnesium metal and aqueous iron 3 chloride. The reaction requires 1,133 kilojoules of energy, telling us that it's an endothermic reaction. So for our balanced thermochemical equation, we have two iron metals plus 3 magnesium chlorides reacting to form 3 magnesium metals plus 2 iron 3 chlorides. The energy is a reactant here because it's an endothermic process, meaning the reactants need to absorb that additional energy before the reaction is going to occur. For our first part, how much energy is required if you want to form 125 grams of iron 3 chloride? So we'll be going from grams of one of the components to energy. So we start with what we've been given. We'll be using the equation editor. So we go to Insert Equation, and we type in 125 grams FeCl3. So our first step is to convert from grams of iron 3 chloride to moles of iron 3 chloride. So we put in our fraction, and we know that 1 mole of FeCl3 has a molar mass of 162.2 grams of FeCl3. All right, so that's going to cancel our grams for us. Now we want to go from moles of iron 3 chloride to the energy part. All right, so this is our mole energy step. We're going to use the enthalpy change, which is in our reaction, and the coefficient that goes with our compound we're working with. All right, so we use our fraction again. All right, the energy needs to be on top because that's what we're looking for. So 1,133 kilojoules of energy. And that is needed every time we want to produce 2 moles of the FeCl3. All right, this 2 in our conversion factor is coming directly from the coefficient. All right, so if we look, everything's going to cancel. We've got the moles canceling and the grams canceling. We're going to be left with kilojoules. So if we use our calculator to do the rest, we find we have 437 kilojoules of energy are going to be absorbed. Oops. If we have 125 grams of the iron 3 chloride produced. All right, so that's how we go from grams to energy. So now we're going to look at how do we go from energy to grams. All right, so we're going to use the equation editor again. Let me scroll this down a little bit. All right, so we insert our equation. All right, we start with what we've been given, 875 kilojoules of energy. All right, this time our energy mole ratio will be first. We're trying to find magnesium chloride, so we need to know how many moles of magnesium chloride. And according to our balanced reaction, 3 moles of MgCl2 and 1,133 kilojoules of energy. So for every 3 moles of magnesium chloride that react, we need to absorb 1,133 kilojoules of energy. That'll cancel our kilojoules. Now we need to go moles to grams, just using a mole ratio step. Molar mass step. And we know that 1 mole of magnesium chloride has a mass of 95.21 grams. All right, if we check our units, cancel the moles of magnesium chloride and the kilojoules, and we're going to be left with grams. So if we do our calculation, we should find that 221 grams of MgCl2 are needed to react with 875 kilojoules of energy. Okay, so that's basically all you have to do. They're 2-step problems in general. You're going to have a molar mass step, which we've worked with before. The new one is this energy mole step. You need the coefficient from the reactions, and then you need the delta H that should be either given in the problem or listed with the thermochemical equation. Okay, if you have any questions, just let me know.